There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium.
Guten Tag and welcome to Dr. Von German's Kitchen of Scientific Fun. Today we are looking at the water. You all know what molecules are. What you might not know is that the molecule of oxygen has a much higher electronegativity. This means that the electrons are more attracted to it. Hydrogen has a lower electromagnetivity. So, when they all get connected into a molecule, the electrons get pulled into the oxygen side more than the hydrogen side. This makes the sharings of the electrons uneven, with a positive and a negative side, so the molecule is polar. A lot of molecules are like this, but oxygen and hydrogen are special because of the difference in electronegativity is higher than most molecules. This makes the compound made of both hydrogen and oxygen, like water, extremely polar. This sort of bonds are called hydrogen bonds and account for a lot of water's special property. Let's do an example. If my lovely assistant could get some salt.
Why, certainly, Doctor.
Danke. Now, look at this. As you can see, the sodium chloride has broken down into sodium and chloride ions. You see, the ionic bond created by the charge of positive and negative ions when the attraction in the water molecules is greater than the attraction between the ions, the ionic compound breaks down. Now, you see, they call water the universal solvent. You can just drop anything into it and it will dissolve. Observe! What? What do you mean? What? But then why did you call it the universal? Why can't I? Okay, fine then, danke. I guess the universal solvent actually isn't. Turns out it can only dissolve polar and ionic compounds, but it can dissolve pretty much any of those. That is because of the high difference in electronegativity in the water molecules, and the attraction from them is greater than almost all ionic compounds and polar molecules. But, you see, if there is an object with no charge in it, the changes in the water molecules will do nothing to it. Because of this, water does not dissolve nonpolar substances which lack a charge like oil. Now, let's stop playing with our balls and do something fun.
Might not work.
Turn
You
around.
want to try and zip it up?
As you should all know, metal does not float in water. But the water is made up of particles with negative and positive ends. They tend to be attracted to one another, pulling the water itself. The result is that one of the water's properties is high surface tension. Molecules at the surface of all liquids get pulled into the liquid because they cannot hold the air, which creates surface tension. But because the water is very polar, the pull is much greater, resulting in higher surface tension. This lets you know the balance between things heavy as a paperclip because its weight is less than the force of the surface tension. But if you disrupt this surface tension, the paperclip falls right in. Now, let's try something different. If my lovely assistant could provide me with some materials.
Why, certainly, Doctor.
As you all know, oil is nonpolar. So, then we add it to the water. Nothing happens. But then we add soap. Something amazing happens. Just a now watch the net. Nothing is happening. What do you mean?